Alright, so in this video we are going to go through the practice for chapter 9. So chapter 9, in my lesson I've explained the 5 steps of conducting a hypothesis test. So a hypothesis test, the purpose is that we have a hypothetical statement about either population mean or population proportion. So we usually don't know what the population mean is, but people can make assumptions about it. People can make certain hypothetical statements about it, right? So, and people often do that. So if you ever want to validate that statement, validate a statement about the population mean or population proportion, we have to run a hypothesis test. So in order to run a hypothesis test, we are following 5 steps. We state the hypothesis, alternative and null hypothesis. So we are testing one versus the other. And then we have to calculate a value called test statistic using our sample. And then we decide on a error rate, alpha, significance level. And then we calculate the actual error based on our sample. And then we basically compare the two to make the final conclusion about the hypothesis, right? So to the side, I will quickly write them down. So the 5-step process before we begin the worksheet. Step 1 is to state H0 versus H1. So you have to read the question and then you have to figure out what should be the null, what should be the alternative, and then calculate test statistic. So for this step, for population mean, so if you're running a test for population mean, test statistic can be of 2 streams. One is a Z approach, the other one is the T approach. So we use the Z approach if population standard deviation. So always standard deviation is the key to decide whether to use Z or T. So if sigma is given in the question, we use Z approach. If sample standard deviation S is given, we use T approach. But for a proportion, we don't have to make that choice. And step 3, alpha, making a decision about alpha, the significance level. So I've explained this in my lesson as well. If it's usually it's given, if it's not given, you always assume 0.05, because that's the most commonly used level of significance. And then step 3, you calculate step 4, calculate the p-value, which is the actual rate of error based on the sample you have. And then step 5, you make the conclusion by comparing the actual to the theoretical error rate. So if p-value is less than or equals to alpha, we reject H0. And if p-value is greater than alpha, we do not reject H0. So in my lesson, when I was actually stating this conclusion for the first time, I made an error saying that this is greater than and this is less than equals. And later on in that video, towards the very end of the video, I corrected it. So make sure that you note that problem. So this is the correct one. So this is the correct way to make the conclusion. You compare the p-value to alpha. If p-value is less than or equals to alpha, we reject H0. If p-value is greater than alpha, we do not reject H naught. So you cannot stop there. You have to interpret your result. It's really important in terms of the practical life and in terms of your final exam. So you must state what your H naught and what your H1 is. This part is critical. So let me point out. So when you run a hypothesis test, let's say for an example, during an exam, you have to run the hypothesis test for mean. So it's extremely important that you provide me step 1. Okay. And then you have to provide me what is the value for test statistic. It's extremely important. Step 2. And then p-value. What is the p-value you get? Extremely important. And then you provide the conclusion, make the right conclusion. And that's not it. In order to get the full marks, you must provide the interpretation. So I'm going to walk you through this process using the chapter worksheets today to give you some practice on that. Okay, right. So question number 1 is a multiple choice question. Let's have a look. A restaurant that bills its house account monthly is concerned. So if it says concerned, probably that is going to give us some idea about the hypothesis. So they are concerned about what? They are concerned that the average monthly bill exceeds 200 per account. So that's their concern. The average is more than 200. So you have the hypothesis, the hypothetical statement given to you in word form. You need to read that, pick the correct hypothesis, and you may have to sometimes convert it into notation. So it is very clear to us that we are dealing with mean, right? Average. And then it is very clear to us that their concern is average is more than 20. So you have to write that down. So you have to convert it into notation. This is their concern. And why did I choose population mean? Population mean greater than 200 because they talk about, in this statement, it is very clear that they are talking about based on all monthly bills, the average monthly bill is more than 200. That's their concern. So this is about the population. It's not about a sample. It's about the population. So this is their hypothesis. Now you need to think, okay, so this is what? This is H naught or is this H1? We know null hypothesis always must have the equal sign. That is the key for you to identify whether it's H naught or H1. So you can see in this statement, we don't have the equal sign. It's just greater than, right? So if we don't have the equal sign, this has to be H1, the alternative. Okay, so alternative can have 3 forms: greater than, less than, or not equals, right? So if this is your alternative, then you need to build. So alternative is given in the question. So once you identify that it's alternative, you need to build the null on your own. So null should be the complete opposite of this, less than or equals to 200. There you go. Okay, so from the list, the last one, E is the correct answer. Okay, right. So number 2, we have this same question. So number 1 was like an intermediate step. We only did step 1 of the hypothesis test, right? So in here, we are going to do all the other steps. So a restaurant that bills its house accounts monthly is concerned that the average monthly bill exceeds 200. A random sample of 12 accounts. Okay, so now we are digging into the sample. We are going to talk about sample. A random sample of 12. That's your sample size, n. 12 accounts selected, resulting in a sample mean of 220. This is your X bar. And a standard deviation of 12. So that is a clear indication the standard deviation 12 is calculated using your sample. It's not the population standard deviation. This is the sample standard deviation. S. So once you see S, this means T approach. Okay. If you have sample standard deviation given to you, you have to use the T approach when you run MegaStat. Okay, conduct t-test. Okay, it's very obvious it's given. Conduct t-test at level of 5% significance. So that's your alpha. Okay, right. So we have everything we need. We just need to learn how to run MegaStat and get the test statistic and get the p-value, right? So I'm just going to roughly write down the steps because so for an exam you must write it in this form. So step 1, in order to get full marks, it is a must that you write it in this form. So now that the exams most probably is going to be online, so I would say you can write down your null and alternative in words rather than using notations. You can use average monthly bill bill is less than or equals $200. That's your null, and then the alternative, average monthly bill is more than $200. Okay, right. And then step 2, we still don't know, but we know it's a t-value, right? Because sample standard deviation. So test statistic is a t-value. T equals 2, we don't know that yet. And step 3, we already know alpha is 0.05. And step 4, still don't know what the p-value is. And step 5, still don't know. Okay, right. So in order to get step 2 and step 4, we need to go into MegaStat. Okay, so in MegaStat, before you start running the MegaStat, you need to summarize your numbers on the sheet. So you open a blank sheet and then you type a label like summary. It can be anything. A monthly bill summary, you can type anything, but just the only requirement is you just need to have a label. And then in this exact order, keep in mind guys, in this exact order: sample mean, standard deviation, sample size. Okay, so I'm going back and read. Okay, that. So sample mean of 220 with a standard deviation of 12 from a sample of 12 accounts. So 220, 12 and 12. So in this exact order: sample mean, standard deviation, sample size. So this 220, don't ever get confused that with 200. This 200 is the value on the hypothesis. That is not your sample mean. Okay, so you have two numbers. So population mean is more than 200. So this is your hypothetical value. 200 is your hypothetical value. 220 is your sample mean. Okay, so sample mean is what you are going to put here under summary. Okay, so once it's done, you go to MegaStat hypothesis test. So we have 1, 2, 3, 4, 5, 6 different hypothesis tests listed here, right? And which one should we use? So as you can see, proportion versus hypothesized, no. Compared to independent proportions, no. So these two are definitely not valid here because we are dealing with the mean, right? And chi-square variance, we are not going to do it at all. Okay, so it's not these last three. So it has to be one of the first three. So first one says mean versus the hypothesized value, compared to independent groups, paired observations. So what we are doing here is we are comparing our population mean. We are comparing the population mean average monthly bill to a hypothetical value. So that's what we are doing. So mean versus a hypothetical value. We are comparing the population mean to a hypothetical value. That hypothetical value is the restaurant managers, it's in their mind, right? So they are concerned it's more than 200. So that's their hypothetical value. So the first one, mean versus hypothesized value. Okay, and then you have two ways that you can provide the input. If you happen to have all the data in front of you, so they say that they have checked 12 accounts, right? So that's their sample. So if you happen to have the numbers for all 12 accounts, you can go with data input. Or if you happen to have the summary of those 12 accounts, which is what we have, you go with summary account. And when you read, it says select the range with label, mean, standard deviation, sample size. That means you click here in the empty space and click and select label, mean, standard deviation, sample size in that exact order. Okay, and then you need to fill out the rest. So hypothesized mean is the hypothetical value that we are comparing the population mean to. So we are comparing population mean to 200, right? 200, and the comparison is the alternative. So comparison is greater than. So we are saying population mean is greater than 200. Okay, so whatever the sign on the alternative, you have to put it over here. And then we already know it's a t-test because 12 over here is the sample standard deviation. And you don't need to do this one because this one is going to create confidence intervals for population mean. And we don't need that right now. So that's it. So don't need to select this one. Okay. Click OK. Right, so once you click OK, it's going to generate the output for you and you are reading these two values. The first value is actually your test statistic. This is the test statistic. And then this is the p-value, 0.0001. So 5.774. Now I can complete the, 5.774. And then p-value is 0.0001. Okay, and the last step is to compare p-value to alpha. So it's very obvious 0.0001 is less than 0.05 alpha. So our conclusion is we reject H note. So now you look into H note. What does it say? So H note is this. So it says average monthly bill is less than or equals to 200. So according to our test, we are going to reject that. So that is an indication since we are testing H note versus H1. So this is an indication we have to accept H1. So that means this is true. So what is this? It means average monthly bill is more than 200. So basically their concern, right? So basically their concern is true. So now the last part, the interpretation part. So we made this conclusion based on the sample we had. So we have to mention that. We have to make sure we mention that. So based on the sample, used, we can conclude that oops, what is going on? Okay, based on the sample we used, we can conclude that their concern that the average monthly bill they are concerned that the average monthly bill is over 200 is a valid statement or a valid concern. Okay, right, so I want all this for a written response question. You have to make sure you give me this complete answer, then you will get the complete mark. So once again, step 1, you state H0 versus H1. You read the question, find where the hypothesis is. Based on that, you do the identification. Is it a null? Is it an alternative? Once you figure out which one it is, you have to build the corresponding other one, right? So basically, we have to have H0 versus H1. And then step 2, test statistic. You get it through MegaStat. Alpha, usually given. If it's not, always assume 0.05. P-value, you have to get it through MegaStat. And then the conclusion, you compare p-value to alpha, write down the conclusion according to the null hypothesis, and then convert it into words. Okay, right. So I'm going to add the next page of the worksheet. Okay. Right, let's have a look at number 4. One of the major US tire makers wishes to review its warranty for their Rainmaker tire. The warranty is for 40,000 miles. The tire company believes, here it comes, the hypothesis. They believe that the tire actually lasts more than that. So they say the average warranty is, they set the average warranty for 40,000 miles, but they believe it's more than that, with a population standard deviation of 15,000 miles. A sample of 49 tires revealed that the mean number of miles is 45,000 miles. Test the hypothesis with 0.05 significance level. Okay, so first look into the hypothesis, build H0 and H1. So step 1, Let's first go through that. So they believe the average mileage is more than 40,000. So that's their belief. So average mileage is more than 40,000. Right? So this is obviously H1. So H naught should be less than or equals to. So H naught average mileage is less than or equals to 40,000. And the corresponding H1 average mileage is more than 40,000. So that's what they want to test. Is it actually more than that? Okay. And then step 2, the test statistic. So first we'll figure out whether it's a t or a z value. Okay, so in order to do that, you need to look into the standard deviation. So standard deviation is the population standard deviation. So it says population standard deviation is 15,000. Okay, so this is sigma, which means z, right? So your test statistic has to be a z value. Okay, we don't know that yet. And then step 3, alpha given 0.05. Step 4, p-value, still don't know. Step 5 still has to make the comparison based on the results. Okay, right, so let's go to, so we have standard deviation. Let me point out the other ones. We have sample mean over here. It says 49 tires revealed, that is your n. 49 tires revealed that the mean is 45,000. So that's your sample mean, x bar. Okay, so 45,000, 15,000, 49. Okay, summary. 45,000, 15,000, 49. MegaStat, mean versus a hypothetical value. Select the summary. And the hypothesized value is 40,000. Alternative still greater than. Now we have to switch to z test, z. Okay, 2.33, 0098. Okay, so this is 2.33, 0.0098. Okay, so I think we are going to land on the same conclusion. P-value is less than 0.05, right? So we reject H naught. That means we have to accept their statement. So they believe that it's more than 40,000, and it is. So based on our sample, studied the average mileage, or they are guaranteed. Is actually 10,000 miles. Okay, right. So I did 2 questions. One is T approach. This one Z approach. Both are for population mean. And then I'm going to do one more for proportion. Let's open it up. 3rd page. So I'm going to go through number 7. Okay. The claim that more than 40% of those persons who retired from an industrial job before the age of 60 would return to work if a suitable job was found. Okay. So this is going to end up exactly same alternative as we've seen the previous 2, but it's okay. So it says more than 40% of the people who retired before 60 are going to return to work if they find a suitable job, right? That is the statement to be investigated. Okay, so that means this is your hypothesis. So you need to figure out whether it's an alternative or whether it's a null. So it's pretty obvious it says more than 40%. So here we are talking about a different parameter. It's also very important you identify that, because we have 2 parameters going on. One is population mean, other one is population proportion. So based on the hypothesis or based on the information given, you can easily figure it out. Because for a question about population mean, you always have the standard deviation. For a question about proportion, you have a sample proportion. Out of this many, this number belongs to the certain category we are interested in, something like that. So if you happen to have that, that is a clear indication it's about the proportion. Or else in the hypothesis you will see a proportion, like here you see 40%. So it says more than 40%. So proportion, this is a question about proportion. And what's this proportion is about? This proportion is about those who would return, proportion of retirees, portion of people who would return to work if a suitable job was found. So if anybody who retired before 60, if they could find a suitable job, they might consider going back into the workforce, right? So the proportion. So that's the exact idea. So we are talking about population. Everybody, all the people in this world who retired before 60. Okay, so this is the population proportion, and the hypothetical statement is this proportion is more than 40%. Okay, so we don't have the equal sign in it, so this is H1, and the corresponding H naught should be less than or equals to 40%. Okay, so this is kind of a lengthier statement when you write it down in words. So you will have to write down H1. So one way you can do is you can define the proportion this like here. P stands for this. This is what simple P means. And then you can do H. So step 1, My H naught is P less than or equals to 0.4 versus my H1 is P more than 0.4. Okay, but it's important you define what simple P means in actual words. Okay, right. And then step 2, test statistic. We don't have options here. It's always a z-value for proportion. And 3 alpha, okay, 0.02 it's given. And 4 p-value, still don't know. 5 conclusion, still don't know. Okay, and I'm going to read further. I only read up to the hypothesis. So I'm going to start over. So the claim that more than 40% of those persons who retired from an industrial job before the age of 60 would return to work if a suitable job was available is to be investigated at the level 0.02 of significance. If 74 out of 200 workers sampled, there you go. This is your sample proportion. Oops. This is the sample proportion. So that's all we need in order to run higher proportion, hypothesis test for proportion. So if 74 out of 200 workers sample said they would return to work, what is our decision on the above claim? Okay, so going back to Excel, you don't need to type anything in the worksheet. You just directly go into MegaStat hypothesis test. It's now you're comparing your population proportion to a hypothetical value, 40% to be precise in this case, right? So you go to proportion versus hypothesized value. Okay, so you have two sides, observed size, that means your sample, hypothesized size, that means your hypothetical value. So you can do it this way, 74 out of 200 and hypothesized proportion is 0.4. We are comparing proportion to 40%, right? And the alternative is greater than. No need to do this part. This is for confidence intervals. It's chapter 8. Click OK. Here you go. So this is the test statistic, the z-value. This is the p-value. Okay. So z-value came as a negative, which is completely fine. Okay. Negative 0.87. Is that, and then p-value is 8068. 68. Okay, so now this one, the conclusion goes otherwise, right? So p-value 0.8068 is higher than 0.02. So we do not reject H naught. Right, so what does that mean? So we do not reject H naught means we are rejecting H1. So that means we are rejecting this claim. It's actually more than 40% of the people will not return to work even if they find a suitable job. So now you have to carefully write that down. So based on the sample, data, we can conclude that more than 40%, you can just copy the complete sentence directly from the question. So you can say, conclude that more than 40% of those persons who retired I'm just going to skip words. Retired before 60. Would not. So that's the only difference. Would not return to work even if they find a suitable job. There you go. And so I'm going to end this tutorial with these 3 exercises because it's just the repetition of the same thing over and over. So all you need is a good practice, right? So you have everything you need to know in this practice session. I just want you to complete the rest of the worksheet, and if you feel like you need more practice, please go ahead and try some chapter exercises, and always let me know if you want me to name some chapter exercise questions for you to try out. Just let me know during the during our office hours, or just shoot me an email. I will send you some questions from the textbook. And what else? So I think that's pretty much it. And yeah, one last thing is that this is one common question students asks me. So from the sample, when you look at your sample, 74 out of 200, this is a lower proportion, right? Sample proportion is low. So some students ask me, so if the sample proportion seems to be a lower number, can we just directly conclude? Why can't we just directly conclude that their claim is wrong? The reason we can't is because this is not the only sample that you can take, right? So from the population, you can take so many different samples with size 200. So this is just one sample we are talking about. So by just looking at the sample proportion of one sample, you can't really project that idea to the entire population. So that's why it's essential for you to go through this process. This process is going to take your sample into account and then think about all possible samples that they can take out of the population with 200 sample size, and it's basically going to project the idea into the entire population. So for proportion or mean, you can really just look at the sample mean and make a conclusion. You have to actually go through the hypothesis test, because sometimes even the sample proportion is low like this, your conclusion may go other way, right? So there are cases like that. So make sure that you don't come to that wrong conclusion. Always you have to run the complete test to figure out whether the statement is true or false.